What's up, geometry? This is lesson 4.3. Our objective is about transformations and congruence. Remember, yesterday we talked about congruent shapes being the exact same shape, the exact same size, but they could be flipped or rotated or slid to a different new position. So today we're going to be talking about transformations that give you congruent shapes, and we call those rigid motion. So a rigid motion is a transformation that preserves length, angles, measures, and area. So pretty much you start and end with the same shape. There are three different kinds of rigid motions. The first one is a translation, which is like a slide. You just slide from one position to the next one. The next one is a reflection, or where you flip it across a line. And then the other kind is a rotation, where you turn it about a point. So if you use any one of these three, you end up with a congruent shape. So this is guided practice number 3 and 4. It says, tell whether the two figures in the quilt are congruent or not congruent. If they are congruent, describe the transformation or transformations you can use to move figure A to figure B. So let's just kind of highlight these a little bit real quick. Here is this shape. Not exact, but pretty much the idea here. Or here is this shape. Now it looks to be almost the same shape, except for, notice this length here compared to this length here. This length seems to be the same as that length, that one same as this one, and those widths tend to be the same. But that one and that one seem to be different thicknesses. So are they the same shape? No. So I would say not congruent. For this other one, it's this shape. And this shape. Me drawing over it probably makes it harder to tell, but I'm pretty sure that those look to be the same shape. So then here, I would say congruent. And then I have to describe the transformation that moved it from A to B. So notice, it kind of looks like, well, maybe there's two different ways. First thing I saw was if I flipped it across that line, it would be a reflection and give you the other shape. The other option would be to rotate it about a point here, right? This shape rotated to that shape would give you that one. So you could do either one of those and you'd get it correct, but I'll say a reflection. Okay. This is number 9 actually from the homework set, and it's a multiple choice. It says, which is not an example of a rigid motion? So remember, rigid motion gives you a congruent shape when you're finished. So we're going from blue to red, it looks like. This shape appears to be the same as that one. Looks like that's a slide, right? Here is one. This seems to be the same shape, but reflected across a line right here. So this would be a reflection. This shape appears to be the same as that one. Looks like they rotated about a point here, right, to get that one. But notice this one, it almost looks the same, but this thickness to this thickness is different. So then my answer for this one would be C, because that one is not an example of a rigid motion. Alright, so another one here. It says, showing figures congruent, tell whether a rigid motion can move the blue figure onto the red figure. If so, describe the transformations or transformations that you can use. If not, explain why the figures are not congruent. So let's just kind of compare here. It looks like this side length is 2 and that side length is 2. This side length appears to be 3 This one appears to be 3. And this side over here is up 3 over 2, over 3 up 2. So that's going to be the same length for this side as well. So it looks to me like they are congruent. So then all I have to do now is to explain what transformation or transformations I would use to get one to the other. So let's see. Looks like maybe if I rotated it from the blue to the red, if I rotated it, I could get it to be this shape. Alright, if I took from here and rotated it to there. And then it looks like I reflected it across that line to get this point here, this point to here, etc. So I'm going to say rotation to clockwise. Looks like 90 degrees. I'm estimating there. Then a reflection across that yellow line, which is the x-axis. Across the x-axis. Boom. Alright. And now one more and then I'll let you guys go. It says Jen described a transformation in the coordinate plane using the notation explain why this is not a rigid motion. So let's just pick some points in here. Maybe let's make a triangle with it, just because that seems like a pretty easy shape. So I'm going to go with here. That's the point that is where x is 2 and y is 0. Let's pick another point, maybe right here. That's the point where x is 2 and y is 3. Let's do one more point, maybe here, where x is 6 and y is 3. Now I just made those up, so that way I can see if I can find the new points. So notice, this is taking all of my x's and it's transforming it into x minus 1. So my x coordinate would be 2 minus 1, which would just give me 1. 2 minus 1 would give me 1, and 6 minus 1 would give me 5. Now the y is changing to 2 times y. So 0 times 2 would give me still 0. 3 times 2 would give me 6. And 3 times 2 would also give me 6. So now I'm just wanting to graph these new points. So maybe if I call this A, B, C, my new point A is going to be the point 1, 0. So that's what we call A prime. B would be at the point 1, 6. 1, 6, this is B prime. And then my C would be at the point 5, 6. 5, 6, that's C prime. So notice, is this blue shape the same as that black shape? The answer is no, it's not. You could say because, well, it made it bigger and changed its shape. So I'll say enlarged because the transformation enlarges and changes the shape. Your homework is on page 245, and you're going to do 4 through 30 even.